We've looked at linear equations. Now we want to look at a specific use of linear equations, and that is that they are representing the equation for a graphical line, a slanted line. A form that you're probably familiar with is the slope-intercept form. That's this y equals mx plus b. And in this form, where y is solved by itself, the number in front of the x, we call it m in general, represents my slope or my slant. We talk a little bit more about that in another video. This constant number that doesn't have a variable with it is telling me where I'm crossing the y-axis. I circled the sign because that is actually important. If it's a positive, I cross on the positive side of the y's. If it's negative, I'll cross on the negative side. So if I have plus b here, I know the ordered pair for my y-intercept is going to be 0, b. Knowing this allows me to take some general information and just come up with the general equation for a line and then generate additional points that might be on that line. Here's an example. If I'm told that the slope is -7/9, so it's a downward sloping slanted line, and my y-intercept is 0, 16, I can come up with the equation by simply saying, okay, wait a minute, this number here on the y-intercept, that's my b, the slope, that's my m. My equation then is simply y equals -7/9 x plus 16. Then I could say, well, if x is 9, I can find the y and find another ordered pair. If x is 18, I can plug it in and find another ordered pair. I can keep doing that and find as many points as I want on that particular line. It gets a little bit more complicated if I don't give you the y-intercept directly. So in this next example, I'm given the slope again, but this time I'm told that it goes through -3, 6. Now I know that's not the y-intercept because to be the y-intercept, I have to be on the y-axis, which means this x value here is supposed to be 0, and it's not. So I can't just use 6 for my b value. What I can do is plug in the m, y equals -2/3 x plus b, and recall that any point that is on the line is supposed to be a solution for the line. That means that if I plug in this x and this y, I will get a true equation. So let's do that. Put the 6 in for y, the -3 in for x, simplify, and then solve by subtracting, and we find that b is equal to 4. Now I've got the two key components. So my final equation is going to be y equals the -2/3 x, which we were given, plus the 4 that we just found. I'm sure some of you have worked problems like that before, and it's a perfectly legitimate method. I'm just not a huge fan of it because I don't like to have to plug in and solve and then plug back into something else. So I'm going to show you another option for finding equations of lines if you don't have the y-intercept. It's called the point slope equation. So if I'm given any point at all, doesn't have to be the y-intercept, and I know the slope, or at least can calculate the slope, I can come up with the equation of the line by just using one formula. In this case, we're going to say x1, y1, or x of 1, y sub 1, is any point. It's the point I'm given that's on the line. M stands for the slope as usual. Then my equation is going to be variable y minus the y1 I know equals m slope times quantity of x, variable, minus the x of 1 point that I'm given. Let me show you what I mean here. So in this next example, I'm actually given 2 points that are on the line. So, oops, I'm not given the slope. But again, in another video, we talked a little bit about slope, and we realized that that is the vertical change over the horizontal change. So what I need to do to calculate the slope is take the difference in my y's, so the -4 minus 3, over the difference in my x's, the 1 minus 2. Remember, you always go the same direction. And I get a -7 divided by a -1, but negative divided by negative is positive. And then I have my slope. Okay, so up here at the top, I've got my general form. So the plain y, the plain x, they stay. It's the subscripted letters that I'm going to replace along with the m, or the slope that we just calculated. So it doesn't matter which point I choose. I try to stick with positives if I can. So I'm going to choose this first point. So in this first point, the y value is 3. So that's why I have y minus 3 equals, and here's my m, what we just calculated, 7. And then my quantity of the x minus, oh, what's the x value up here? It's 2. Distribute, simplify, and solve, and you have y equals 7x minus 11. Now I want to show you something really cool because I want you guys to get good at checking and knowing how to know that you have the answers and not rely on any kind of system to tell you that. So if I go to my calculator here and I plug in this final equation, 7x minus 11, okay, and I'm going to go ahead and go to zoom and number 6, which will help me get to the standard 10 by 10 window. There's my line. Now I can do a couple of ways to check my answer. I can just hit this button here that says trace, but I want the calculate, or you can just hit trace actually, and we'll put in 2. So then it says, okay, you think x should be 2, and I hit enter, and it'll tell me the y value associated with that for this particular line I just graphed is 3. Yay, because that is what point I was given. Let's try it again. If I hit trace and I type in 1 and enter, it's going to tell me -4. Again, yay, because that was the point that I was given in the original problem. If you don't like doing it that way, you can also go second and then graph button to go to the table and scroll back and forth there to make sure that the points you're looking for are up there. Let me know if you have questions.